Hello, my name is Emir Leslie. I'm a doctoral student with California Intercontinental University, and today we'll have a discussion on conducting a simple regression. This is our agenda. First, we're going to start with the terms and definitions. Then we're going to move into the regression data set. Following that, we're going to have a discussion on the 3 results and the 2 significant results. After that, we'll discuss some important takeaways, and then we'll end with the conclusion and take questions at there. So looking at the terms, the first term that we have is the beta coefficient, or the beta, or coefficient separately, which is the estimate resulting from an analysis performed on variables that have been standardized so that they have variances of 1. Next is the confidence interval, which is the probability estimate of how much reliance can be placed on the findings. The usual accepted level of confidence in social science research is 95%. Following that, we have the regression analysis. This is used in a situation where one or more metric independent variables is or are hypothesized to affect a metric dependent variable. Next, we have the term regressor, which is the independent variable, also known in a statistical context as regressors, which represents inputs or causes. And our final term is the variable slope, which is a hill slope from the data, and it's preferable when there's plenty of data points. So our next slide is the regression data set. So these were taken from the SurveyMonkey, asking participants in the Midwest United States questions regarding their income, debt, savings, and other important personal finance factors in order to put this data set into the PSPP in order to perform it. So as we see, our first regression data set is going to be the dependent variable of debt and the independent variable of income. The second regression set is the dependable variable of savings against the independent variable of income. And the final regression set is the dependent variable of stocks against the independent variable of savings. So as we look at our first regression hypothesis, the null hypothesis states that the slope of the regression coefficient beta is 0. And the alternate hypothesis states that the slope of the regression coefficient is non-zero. So as we did the testing, we noticed that there's a simple linear regression being conducted to determine whether the debt could be predicted from income. And then we found out that there was no significant regression was found based off the beta being negative 0.05, the r squared being 0.00, and the p-value being 0.535. Our next data set was found to be a significant result. Again, the regression was conducted, and the null hypothesis states that the slope of the regression coefficient is 0, while the alternate hypothesis states that the slope of the regression coefficient is non-zero. So when the linear regression was conducted to determine whether savings could be predicted from income, a statistically significant regression emerged where the beta was equal to negative 0.91, the r squared was equal to 0.82, and the p-value was 0.00. Thus, with this, the test rejected the null hypothesis of the slope of regression coefficient being 0. The last regression hypothesis test that was performed is in regards to stock and savings. So we notice that the null hypothesis states that the slope of the regression coefficient is 0, and the alternate hypothesis states that the slope of the regression coefficient is non-zero. Finally, we did a simpler linear regression where to determine whether stocks could be predicted from savings. A statistically significant regression emerged where the beta was equal to 0.28, the R squared, or R2, was equal to 0.08, and the p-value was equal to 0.00. Thus, with this final regression test, we found that the test rejected the null hypothesis of the slope of the regression coefficient being 0. So with this regression test being completed, and we have two significant results out of the 3 data sets, some of the takeaways that we have is that we notice that the PSPP can perform linear regressions, and that can be done easier than through a calculator. The next takeaway that we have is the ability to perform a regression using the PSPP done by going through analyze, regression, and the linear mode. Next is the takeaway is it is important to obtain the coefficient, the confidence interval, and a regression in order to properly calculate and assess the results being significant or non-significant. The example that was used, the initial example that was used was insignificant. However, we need to make sure we work both the significant and insignificant regressions, and that gives us a totality of looking at the null and alternative hypothesis to determine whether this is beneficial or not. And the final takeaway that I have is regressions, they don't have to be difficult. They sound very complex in its term, but the regression itself is a very simple mathematical exercise based off of statistical analysis. So that concludes our discussion. I want to thank you for taking your time to be part of this discussion. And I'm going to take questions now in regards to any of the definitions that was brought up. The regression data sets, if there's any questions on the 3 data sets that were used, and also the results, the results being 1 insignificant and 2 significant results. And finally, the takeaway, any questions that you have. So please, if you have any further questions, make sure that you do post them so I can get back to you on them. Thanks again, and God bless.